So in this TA session, all in this TA session for biointerface engineering, we'll first discuss the what were covered in the lectures, and then we'll solve the assignment problem. So the topics that were covered in week 7 were there were 3 topics: lecture 19, 20, and 21. And in lecture 19, surface modification and objectives of surface modification, few examples of surface modification, all these things were covered. So when in our previous lectures, we saw that we need a host cell response when the biomaterial implant or any biomaterial is exposed to the body. We expect a host cell response. Now, to get this desired host cell response, we have the option to modify the surface of the biomaterial implant so that we get appropriate host response according to the applications. And these surface properties can be changed by various techniques. But in this lecture, only the objectives of surface modification were discussed. So after the implant is after the biomaterial is implanted in the body, whether you want it to integrate with the cells, so whether you want your implant to be more cells to adhere to the implant and integrate with the implant, or whether you want it free from pathogen, or biofilms. If you want it free from pathogen or biofilms, or if you want to integrate. So if depending on the application, we need to change the surface modification accordingly. So there are several objectives of surface modification. First, it can be decreased bacterial attachment. Or to reduce the bacterial adhesion to the surface. So there are several antimicrobial agents earlier that were used, such as silver, but this can also lead to some toxicity. So there are other techniques like using cell wall disrupting agents, such as using cationic surfaces. So the bacterial cells are mostly negatively charged, and if you use positively charged surfaces, then that will introduce strong interaction with these two, and that will lead to prevention of cell elongation and proliferation of these cells, because it's now adhered strongly to the bacteria. That will prevent use bacterial attachment. Then one more technique is low surface energy coating. So the delta G of adhesion is given by surface tension of cell surface minus surface tension of cell liquid minus surface tension of surface liquid. So if we decrease the surface tension of the surface liquid, then we can decrease the delta G of adhesion, and the low surface energy will have less coating of the bacteria on the surface. There is one more technique called brush coating. So the implant can be either coated with mushroom coating, or it could be coated with brush coating. So these mushroom coating, even though it is covering some surface area, there is still chance that bacteria can come in contact with the bare surfaces and then they will attach and proliferate. So it cannot prevent much bacterial adhesion, whereas these polymer brush coating, they can be, they are like brush, and they just drift here like airbrush, preventing the entry of bacterial cells towards the surface, and they can cover more surface area as compared to the mushroom coating. So these, and we can use polymers like polyethylene oxide or polyethylene glycol for these kind of surface coatings. So this is how the bacteria we can achieve the objective of reduced bacterial attachment. Then next we have regulate protein adhesion. So for protein adhesion, to regulate protein adsorption, we can either to use hydrophilic surfaces. They prevent attachment of proteins to the surface, or we can coat the surface with polymers, ceramics, or self-assembled monolayers and biomacromolecules, either hydrophilic or hydrophobic. If we want more protein attachment, we need hydrophobic, but we want less protein attachment, we can go for hydrophilic. So depending upon our interest, we can regulate the protein adhesion by regulating the hydrophobicity or philicity of the material by coating it with polymer, ceramics, or self-assembled layers and biomacromolecules. Then next objective was cell adhesion. To regulate cell adhesion, and we can use prepare biomimetic surfaces. Uh, so in some cases we want integration, such as with bone implant, we want the cells to integrate with the implant. Whereas in case of sutures or pacemakers for heart, we don't want the cells to adhere and cover the surfaces or integrate them with the body. So we want less cell adhesion. So to regulate these kind of techniques, we can prepare biomimetic surfaces as well. Next objective that was covered was designing anti-fouling or self-cleaning agents. Uh, Self-cleaning. So basically, we can. So here we get to know about super hydrophobic or super hydrophilic surfaces. So in super hydrophilic surfaces, if there are contaminants or uh, unwanted adhesion on the surface, the super hydrophilic surfaces they allow the water molecule to slip through this uh, surface below the surface that will remove this contaminant out. And in super hydrophobic surfaces, there is attachment. The water molecule will basically attract this along with it to remove it from the super hydrophobic surfaces. So these are uh, self-cleaning surfaces. These can also be used, or there is one more objective of reduce friction or wear. So to reduce friction, we need smooth surfaces. So basically, such as the bone implant or knee joint replacement implants, we want the implant such that it doesn't hinder the movement and smoothly glides with our joint. So to reduce friction in such cases, again we can use polymers or coatings. And then the next objective was corrosion or degradation resistant. Sometimes these kinds of implants we don't want to degrade because they are for structural support. So in that cases we want it to be degradation resistance or corrosion resistant. So we can use inert layer, coating of inert layer on them to prevent this degradation. Now these even after or to achieve these objectives and to initiate interfacial interaction, also need to take into we need to consider about the surface chemistry, the composition, the wettability, the Young's modulus, coating thickness, and the finishing of coating. All these things need to be carefully noted before we to achieve our objectives with the surface modification for a appropriate host cell interaction. Now in lecture 20, different surface modification techniques were discussed. They can be broadly classified into physical modification, chemical modification, or biological modification. So the physical modification basically uses plasma or laser. Chemical modification uses polymers or self-assembled monolayers. And then biological modification includes immobilization of the surface with biomacromolecules such as proteins and nucleic acids, which can be DNA or RNA. And then in the lecture, we also see some specific cases of specific techniques for this physical and chemical modifications. For example, in physical modification, physical modification, we discuss the different techniques. The most common method in physical modification is, for example, uh, with physical vapor deposition, we have a solid and we want our surface to coat with this solid material. So they vaporize this solid and then this vapor is coated onto the surface of the implant or our material of interest. And this is different from chemical modification in the sense in chemical there is basically liquid or gas which are converted into vapor phase and then they are coated onto the implants. So these are physical vapor deposition or chemical vapor deposition. There are other techniques in physical modification as well, such as lithography, 3D printing, UV treatment, spin coating, etching, and few more of these techniques were also discussed. So, in plasma spraying, which is one of the physical modification technique, uh, high voltage is used, and high voltage, high voltage, and a inert gas is used. So the ionized, this high voltage turns this inert gas into ions, and the ionized inert gas then forms a plasma cloud, and this cloud is then used for coating the material. Similarly, there is electrophoretic deposition. So based on what kind of charge you want your surface to be deposited, you can either place your charge on the cathode and anode and similarly choose appropriate solution. And then etching, another method of physical modification. So it can be dry etching or wet etching. So in dry etching, without use of liquid, the surface is modified, but in wet etching, in presence of chemicals or liquids or chemical solutions, uh, the surface is incubated with them, that basically etches the surface of interest. So these were all the methods of physical modification. And then if we look into chemical modification, uh, similar to physical modification, as I said, there is vapor deposition wherein liquid or gas is used, that is turned into vapor and it is coated onto a heated surface. Then we also have self-assembled monolayers. So interaction of the molecular constituents from a solution or gas substrate with themselves leads to this self-assembled monolayers. So these self-assembled monolayers, there are two different, either selenization or thiol modification. So uh, using the thiol, we can use it for coating on a gold surface. And similarly, selenization can also be performed. So the materials with functional groups are basically used and they are exploited for coating in these cases. And then we talk about biological modification, how using uh, cross-linking and conjugation, we can attach several biomacromolecules such as protein, DNA, RNA, etc. onto the surface. So these were all the surface modification techniques discussed in lecture 20. And after discussing about the objectives of surface modification and different techniques of surface modification, lecture 21 then discusses about a specific case wherein a titanium implant was used. So this titanium implants are basically used for bone tissue engineering, and it is a biologically this is the alloy and it is biologically inert, mostly used for the bone tissue engineering or bone implants. And this uh, this implant was taken as a substrate and then it was coated with calcium phosphates, and effect of these coating techniques was studied. So calcium phosphate is basically found in bone and teeth, and it has both hydroxyapatite or tricalcium phosphate. And if there is a mixture of these two, it is called biphasic calcium phosphate. So hydroxyapatite is basically calcium phosphate, calcium And then the tricalcium phosphate is again another kind of calcium phosphate, PO4 whole twice. Mm, the mixture of this is usually used for bone fracture, bone implants. And so in this specific case, first a RF magnetron sputtering was used to coat these materials on the surface of the titanium. Then its thickness was measured. And then its thickness, surface roughness, wettability, all these parameters were discussed, and we saw that decreased contact angle with increasing surface roughness, there was a decrease in contact angle, theta. And we also establish the uh, Menzel equation, that is cos theta roughness is equals to RF cos theta true, where RF is the roughness factor. And for theta less than 90 degree, uh, the theta decreases with increase in roughness, and for theta more than 90 degree, theta increases with increase in roughness. So quoting the same, and then they went on to quote the same thing, same implant with same materials using laser cladding. And here hyaluronic acid, hydroxyapatite as well as titanium hydroxyapatite mixture, both of them were used for coating. Titanium, the titanium hydroxyapatite is more hydrophilic in nature. So these two were used by laser cladding and coated onto the surface. And again, the wettability and surface roughness, all those things were checked. And this higher the surface, more higher surface roughness was observed in terms of laser cladding. And then also protein adsorption and cell adhesion were also checked for this technique. And finally, another coating using the biphasic calcium phosphate TiO2 and biphasic calcium phosphate and TiO2. These two were again at different concentrations, three different concentrations were coated. And again, we check the contact angle, the surface roughness, protein adsorption, and cell adhesion. So all these were the topics covered in this week in lecture 19, 20, and 21. And now we'll try to solve the assignments that are based on these lectures. Okay, so here is the first question. What is the role of surface modification in biointerface engineering? And the options are to tune biointerfacial interactions, to increase the material density, to tune the material crystal structure, for de novo alloy fabrication. So here the correct answer would be to tune biointerfacial interactions. So materials that we use for specific applications, they are intended to interact with the biological systems, and the surface basically interacts, not the bulk property. That's why it plays an important role in interactions. The interactions determine the host response towards the materials respective to the application. As we discussed in the lecture, the objectives, whether we want bacterial adhesion or normal cell adhesion, we want it to more proteins to adhere to it or not. All of these applications or interactions basic with the bioimplant determines the further host response towards this material. So the main role of this surface modification is basically to tune the biointerfacial interactions. Here is the next question. Which of the following is or are surface modification approaches? Options are low surface energy coatings, polymer brush coatings, positively charged surface fabrication, or all of these. Which of the following is or are surface modification approaches? So here the correct answer would be all of this. These are all surface modification approaches. Applications of positively charged surfaces, low surface free energy coatings, polymer brush coatings. So as we also discussed in the lecture summaries, to reduce the bacterial attachment, we can use all these modification approaches, that is using positively charged surfaces, low surface free energy coatings, or polymer brush coatings. Here is the next question. What type of surface interactions result due to the positively charged surfaces? Hydrogen bonding, hydrophobic interactions, electrostatic interactions, or van der Waal interactions. What type of surface interactions result due to positively charged surfaces? What would be the correct option from these? Okay, so the correct answer would be electrostatic interactions. So here we need to focus on the word positively charged. Positively charged surfaces will interact mostly with negatively charged objects or surfaces. So these positively charged surfaces basically result in electrostatic interactions, and strong electrostatic forces between the adhered cells and the surface impede cell elongation and subsequent cell division. Further, the adhesive electrostatic bond weakens with increasing ionic strength, which is inevitable in most biological systems and many industrial applications. And microorganisms produce extracellular or polymeric substances that interfere with electrostatic interactions. So, though this is a um, that is positively charged surfaces, modification of the surfaces with positively charged ions is a technique for a surface modification technique, but these are the major challenges that we need to look through, and they interact with negatively charged cells mostly, and they impede the cell elongation and subsequent cell division. So the correct answer would be option 3, electrostatic interactions. Here's the next question. What is the effect of increased density of polymer brush coating on cell adhesion? The options are decreases, increases, exponential increase, or no effect. What would be the correct option for what is the effect of increased density of polymer brush coating on cell adhesion? So the correct answer would be increases. I'm sorry, decreases. What is the effect of increased density of polymer brush coating on cell adhesion? So increasing the density of the polymer brush will decrease the cell adhesion. So as you can see here, polymer brush coatings, these are basically grafting of soluble polymers like polyethylene oxide at one end to the substrate surface, leaving the other part dangling in the solution. So there are two different kind of coatings, mushroom and brush. The mushroom coating still have some surfaces, and the cells can easily come and attach here or adhere to the surface. But here the brush coatings leaves less space for the cells to come into touch, and since the free ends are dangling here, they interfere with the cells from entering into or near the surface as well. So the deposition of cells decreases with increasing grafting density of the polymer brush coating. So the correct answer would be decreases. that is increased density of polymer brush coating will decrease the cell adhesion. Here's the next question. Which of the following can be used as anti-thrombogenic surfaces? Options are heparin coated surface, albumin coated surface, alginate coated surface, or none of these. Which of the following can be used as anti-thrombogenic surfaces? So the correct answer would be heparin coated surface. So if we coat the surface with heparin, it will act as so if we coat the surface with heparin, it will act as anti-thrombogenic surfaces. So if we discussed before, so the role of thrombin is basically converting this fibrinogens into fibrils that ultimately forms the clots. So if we want to prevent the fibrin clots, we can coat the surface with heparin that will act as anti-thrombogenic surfaces, or that will prevent formation of clots on the surfaces. So the correct answer here would be heparin coated surface, option A. Okay, so here is the next question. Which of the following strategy can be used to reduce surface friction or wear? The options are hydrophilic surface modification, hydrogel coatings, polymer coatings, or all of these. Which strategy can be used to reduce surface friction or wear? So the correct answer here would be all of these. So to reduce friction and wear, high lubricity is required. High lubricity is basically required in the bone or joint implants to reduce frictions and wear. So hydrophilic modifications of surface increases the liquid on the implant surface, which acts like synovial fluids without just sticking to the surface and hindering movements. So it will just glide on the surface. So hydrophilic modification. Then we have coatings with polymers or hydrogels. These also act similarly. It provides a smooth surface for fluids like the synovial fluids to glide upon it, and it will reduce friction and wear. Okay, here is the next question. Which of the following methods is not used for surface modification? Options are surface grating, surface crafting, lithography, BCA assay, self-assembled monolayers. Which is not a surface modification method? So the correct answer here would be BCA assay. So all the other options such as surface crafting, lithography, lithography or self-assembled monolayers are some kind of surface modification technique, whereas BCA assay, it is just a protein quantitation assay. So this is mostly used to determine the concentration of protein in a solution. It is a colorimetric method, whereas grafting, uh, using plasma grafting, radiografting or photografting, we can coat a surface or modify a surface by grafting the polymers onto the surface. Then we have lithography, uh, which is basically patterning, and self-assembled monolayers as well. So we can create patterns on the surface using these techniques. But BCA is just a protein quantitation assay, and so it is not a surface modification technique. So BCA would be the correct answer. Okay, now here is the next question. Which of the following is not a physical modification method? And the options are electrodeposition, lithography, electrospin coating, or silanization. Which of the following is not a physical modification method? We had talked about three different modifications: physical, chemical, and biological. So here the correct answer would be silanization, whereas electrodeposition, lithography, and electron spin coating are part of physical modification as covered in the lecture. Physical vapor deposition, evaporation, sputtering, electrodeposition, lithography, 3D printing, roughening, hydrothermal treatment, UV treatment, and spin coating. So like this, the electrodeposition, graphy, and electron spin coating are part of physical modification, whereas the silanization, which is basically self-assembled monolayers, is a kind of chemical modification where basically the uh, functional groups, different kind of functional groups are exploited for coating the surface. So in case of selenization, it is dipped in silane solution, and then these are uh, assembled on this silane molecules are assembled on the surface of required interest surface of the material of interest. The process is called selenization. So basically this is a chemical modification technique and not a physical modification method. So option D would be the correct answer, selenization. Next, here is the next question. Which of the following is not a method of biological modification? Options are immobilization, lithography, cross-linking, or conjugation. Which of these is not a biological modification? So the correct answer here would be lithography. As discussed in just the previous question, lithography is part of physical modification technique, whereas immobilization, cross-linking, or conjugation are different kinds of biological modification. These techniques are used to coat the surface of biomaterial with biomacromolecules such as proteins, peptides, peptoids, nucleic acids, lipids, or carbohydrates. So the correct answer would be lithography, option B. Here's the next question. Which of the following is non-reactive plasma gas? Options are nitrogen, helium, argon, or oxygen. Which of the following is non-reactive plasma gas? Okay, so the correct answer here would be oxygen. So oxygen is reactive. Apart from this, nitrogen, helium, argon, and hydrogen, these are non-reactive plasma gas. These can be used for physical modification techniques. So this was all the assignment problems for this week. You want me to go through any question again? You want me to discuss the XRD problem of these two. So these two are part of the next assignment. Uh, I cannot solve the assignment per se, but I can give you a hint. So the fraction experiment that question Okay, so for that fraction question, if you go through the lectures, you'll see for the contact angle for two different contact angle, the relation is like the cos theta of contact angle of A on B is equals to the fraction of 1 and its contact angle plus the fraction of the other component and the contact angle. So in that question, this value is given. These two values are also given. So you'll get a relationship here of uh, FB into some value plus FA into F naught into some value equals to, this will also be something, and these fractions also add up to be 1. F naught is this equals to 1. So this way, if you put the values here, you'll get one equation for that, and this will be your second equation. So if you try to solve these two equations, you'll get the answer for that question. And for the next question, the XRD question that you are asking, the D spacing. So the relation is like n lambda equals to 2d sine theta equals to 2d sine theta, and here lambda is usually known for copper, which is 1.54, and the theta is given in that question, and you have to find d. N you can take 1. So if you use this relation, you'll be able to solve that question. I hope I was able to give you some hint. You try to solve using these problems, and I'll share the detailed solution uh, after 28th March, and we'll upload it in the Google Drive, and you can access the solution if you still have doubt with the solving. Apart from this, do you have any other doubts? Or do you want me to go through any other question? Hello? Hello? Am I audible? Okay. If you don't have any doubts, we can close this session, or I can wait. If you have some other doubts, you can type it out if you're not comfortable speaking. Do you have any questions or any other doubts? Okay. Okay, then I'll try to solve the assignment for the next week and I'll upload it on Google Drive. And this session was also recorded and it will be uploaded on YouTube. So you can refer to this and uh, try to solve the next assignment. All the best. Exam will be having same ones. It might or might not have the same ones, but similar kind of problems you can expect. Yeah, I can't say whether it will the same question will come, but you can expect similar kind of numericals and uh, other questions, theoretical questions. Okay, thank you for joining. All the best for the exams. Bye.